realized they changed the Sundays Mondays.
Nobody emailed you? Who's your tutor?
We can have.
They only emailed us about Tuesday and Thursday, Tuesday and Wednesday.
He did say there were minor changes.
Who said that? When?
Friday.
Okay. So you were told? Yeah.
We're still having Monday blues.
I see that.
Sir, at this rate will be done in 2 weeks.
I know, pretty freaky, huh?
Yeah.
But
Is that normal?
But these last few lessons are not 1 hour lessons because they're so difficult. So like,
It's the integration stuff that's hard, right? That's it.
there's probably like 3 weeks left, but then we also have to talk about the coursework.
Oh.
What are we on? March? April? It's about 4 weeks. But
We still have a month.
yeah, yeah. But also, I don't know. I might give some time over to Charles, so I might not get through the same rate of 5 per week. Maybe I'll get through like 3 or 4 per week. It depends on how the Charles goes, because we have like 7 weeks or something till Charles.
Can we
Yeah, it's the 5th of May.
do
Yeah.
practice papers during tutorial? Because
I was going to do a practice Charles exam a little bit later because there's 3 exams that I have which aren't on Moodle.
no, if not the Charles exam, the normal NCU.
Oh yeah, no, we'll be doing that
Which
for
one
sure.
is more difficult?
Charles.
I think it depends on your background. Alright, we'll start now.
Which background is easier for NCUK?
I think the M2K exam is a little bit easier only because you've been preparing for it for like months.
Yeah.
Whereas the Charles exam has some stuff in it that you kind of have to squish in, you know? So it's, if you've seen it before, it's alright, but if you haven't, you'll find it's a little difficult. Alright, we'll start now. Guys, we'll start now. Guys, now, Amjad, this week, are you doing Charles? You are, okay, so this week we're starting the Charles revision. Okay, we're not too far away from the end of the book, and we now really need to be thinking about the final exam. Okay, so no more messing about in class, okay? A little bit more focus. Yes? No, from this week. I think it's on Wednesday. I'm not 100% sure. It's Wednesday. Okay, so. No, the maths one I think is 4 to 5. I think.
It's not on the schedule.
What does it say?
It says
Is Charles?
there's we have
No,
chemistry
chemistry.
tutorial, break, then chemistry preparation.
So I think what's happening is there's a 3-hour block. I think.
Yeah.
And I'm in the middle slot
Okay.
for maths. Then I think chemistry is the last slot, so it must mean biology is the first slot. Yeah? Okay. Alright, why has this stopped projecting now?
Sorry, the Charles.
Oh, don't touch it. Yeah.
The Charles maths exams, maths prep. Is it going to be useful for
That's what I said.
The N2K?
no Irish universities? Like in
Yes.
courses at Irish universities.
Yes, there's a bit of an overlap with the Irish math syllabus,
Okay.
so it's good. Alright, so good, this is projected now. Can we see this okay? This room's not as great as D213. I don't know, it's swapped, and I don't understand why, but anyways, could somebody maybe move the projector a bit more to the left, please? Not you, yeah, that's okay. Are you tall enough to? Mo can do it, alright. Yeah, a bit more. There, that's grand. Good. Thank you, Mo. Alright. So, last week we were looking at the product rule and the quotient rule. So this week now, we're looking at the chain rule. So we've seen how to do problems like this. We know how to calculate, for example, log x times sine x. This we can differentiate. That is A-OK. And something like log x over sine x, that's also A-OK. Now, what we'll have a look at today is log of sine x. Now, please don't confuse that with the first one. It's quite common that people think that this is the same as log x sine x. Okay, this is log of sine x. The sine is inside the log. That's the type of problem we're going to have a look at today. Okay, so we'll see how to do that now. Can I scroll down a little bit? Like to hear? Yeah. Now, the rule is actually pretty straightforward. It's like a substitution. What you do is you substitute u as whatever the inner piece is. So the inner piece here is sine x. Then you write down its derivative. So du dx is equal to, so in this case it will be cos x. Okay? And then you go back to the original question. So this is changing to y equals log u, because we're saying u is sine x. And instead of having dy dx, we have dy du, because we're using u instead of x. So what's dy du? That's 1 over u. Now, yeah, this is where we have to combine our answers. So if you were to take this answer and take this answer and multiply them, see what you get. So you'll have dy du times du dx equals 1 over u times cos x. Now you are able to cancel the du's. So this du cancels with this du and you're left with dy dx. The only problem with this answer is it has a u in it, and we should have it with an x. But that's no big deal because we know what u is. What did we say it was? Sine x. So the answer is cos x over sine x, which, if you're wondering, is the same as cotan x for anybody who's seen it before. You don't really need to know that, but if you've seen it before, you can write cos over sine as called cotan x. But no big deal if you haven't. Okay, you can leave your answer like that. It's perfectly fine.
So we don't need to simplify it.
Don't need to simplify this, and that's one of 3.
Oh,
Yeah.
I'm not sitting this wrong.
Hey, do you want to use up another
That
question?
was a statement.
Do you want to use up another question? Do you want to use up another question?
Good.
Okay, you're good. Thank you. Okay. Can I scroll down? Okay. Can you see okay, Young Payne? Yeah. Have you guys seen this before, or is this new? You've seen it before?
The way I took it was a bit different. Like, there was
Yeah, I'm going to show you another way to do it.
derivative of the outer. Then
Yeah, that's
the
what I'm
inner.
going to show next. Yeah,
I've
a
done
little bit
only
more
AS.
compact.
I've done only AS, so I've not seen this.
We'll do another example. You got that in pen? Yeah, you sure? Okay, scrolling down. So here's our next example now. We have y equals, let's say, x squared. So the trick is, again, you let u equal x squared. So du dx,
Equals
2x. You go back to the original, and you have y equals eu, because we're saying u is x squared. And we differentiate this. We have dy du equals eu. This answer, we multiplied by this answer. So we have dy du times du dx equals eu times 2x. That's good because again the du's cancel and we're left with what we're looking for, which is dy dx. So all that's left to do here is to substitute in what the u was, which we were told at the beginning was x squared.
Yeah.
Now there is a shorter way to do this, but I just want you to practice this method. So I'll give you one to try. We'll say y equals x squared plus 1 power 6. And I'll give you a little hint. What should you make u equal to here, do you think?
X squared.
Yeah. You should let u equal x squared plus 1. Okay? So I'll give you 1 minute to try this one now. Can I scroll down a bit? Yeah, you got that? Oh, no, sorry, you're too late. You'll have to come back for the second class. Okay. Well, we have a look at the answer for this one, yeah? Okay, so y equals u power 6. And also u equals x squared plus 1. So here dy du equals 6u5. And here du dx equals 2x. And dy du multiplied by du dx gives me
6.
dy dx, yeah? Yeah, if you multiply those two. Can you see that? Because the du's cancel. So that's equal to 6u5 times 2x. So that's equal to 12x u power 5.
Yeah.
Like that. Yeah. Is that okay?
Is it okay if you left the last part till the end? After you,
Which part?
like, I wrote it as 2x, 6x squared plus 1,
You wrote as
5, and then at the end I did the 12. Okay,
Oh, yeah.
that's fine.
Huh? What? I can't understand how people can be so stupid sometimes. Do you have a death wish, Amjad? Do you want me to come down and strangle you?
I don't know what he said.
Okay, have you got that? Have you got that? Yeah. So you don't have to go through all this procedure. There's actually a short way to do it if you're comfortable enough. So I'll show you maybe with the 3 examples I did the short way to do it. So what was the first one I did? Log sin, well actually you have the examples in front of you. So the first one we did was log sin x.
Log of sin x. Yeah.
Log sin x. So the way you do this is you identify the 2 parts. So you first identify the sin x as the inside part, And then you identify the outside part, which is log x. Okay? Sahra, Ahmed, Sahra, take the earphone out. Okay, I need you guys listening. If you're not listening, then you're going, okay? You too. Right, so here you have log sine x. So you identify the inside and the outside. So the sine x is the piece that's on the inside, and the log x is the piece that's on the outside. And the quick rule is, what you do is you differentiate the outside first. So log of x, or log of a thing, is 1 over that thing.
Yeah.
So log x is 1 over x. So log sine x is 1 over sine x. And then you multiply by the inside's derivative. So derivative of sine, cos. Now you see, that's a lot quicker if you're comfortable doing that. Let's take another example. What was the next one I gave you? E, was it?
X squared.
EX squared.
EX squared. Now, what is the outside here? Is it the x squared or the e? The e. And the inside? X squared. So the rule is you differentiate the outside. So what's the derivative of EX?
Yeah.
EX. And then derivative of x squared? 2x. Okay, what was the next example we did? Was it the power one? Power 6.
Yeah.
Now this one's a little bit harder. What is the inside and outside here? So what's the inside?
X squared plus.
Yeah. And the outside is
6.
power 6. Power 6. So what's the derivative of power 6? You bring the power down, reduce the power by 1. So that's 6x squared plus 1, 5. Yeah. And the inside derivative?
2x.
2x. So let's practice a new one. Let's try sine of log x. So derivative of sine? Cos. And then derivative of log x? 1 over x. You see? So this is the chain rule for quickly differentiating chains. Okay, so see, you can't really write anything down because you jump to the answer straight away. Question? Go on.
So, when NCUK, how long is the chain there? Or how long can it go?
So what I've seen, they usually mix it like a product and a chain, a quotient and a chain. I don't think I've seen a double chain. I don't think so. Like log of sine of EX.
So the longest you've seen is like a double chain? Or you have even seen that?
I haven't seen a double chain. Huh? Well, I'm going to do an example now.
So you do one chain first.
Okay.
Same way. Okay.
Question? If this is okay? Is this how you did it before? Is this how you, this is what you were saying? You did it this way before? Yeah. Yeah. Just straightforward. Okay. Do you have that? Or can I scroll down? Can I scroll down, guys? Yeah? Okay. So let me give you a trickier one to try. Let's say I have something like this. Y equals EX log sine x. It's a product and a chain. So the product is because it's EX times log x, and the chain because it's log of sine x. I'll give you a minute to try this before I give you the answer. got it done? Easy peasy?
Yes.
Yeah?
Once you differentiate this one, you don't have to put it again for the next part.
Alright.
So you're done.
Yeah.
Finished?
I keep on making that mistake. I made a mistake here.
Are we ready to see it? Yeah. So, product rule first. First we differentiate EX, so that's EX, and we keep the other guy the same. Then we keep EX the same and differentiate log sine x, which requires the chain rule. So the derivative of log is 1 over,
Sin x.
and derivative of sine,
Cos x.
cos x. And that's it. That's it. Okay, let me give you just another one. So let's just say sine
Go ahead, question drop.
2x plus pi, yeah, that's where I'm going with this, over log x. Try this one.
What was it? That's space.
So, is there like a rule for the order? So, like, if there's 3 rules.
It depends on the type of problem. So this one is quotient and chain, whereas the other one's product and chain. So my experience is usually the questions are designed so that it goes quotient, product, chain. But that's not like a rule. That's just my experience that it seems to be this kind of order of preference in the exam.
Because you can have quotient into a product into a chain.
Yeah.
So
That's the idea, yeah. So, but I mean,
they don't get that.
no, but you could have the product first and the quotient second. It's just they don't do that in the exam. So, anyways, Savi, my experience is first quotient, then product, then chain. Okay. Can I have a look at this now? Yeah. Yeah. So, the rule is it's the bottom squared, the bottom times derivative of the top, and sine becomes cos 2x plus pi, and the inside derivative is 2 minus the top
1 over x.
times 1 over x, the derivative of the bottom. And that's the answer for that. Yeah.
How do you use chain rule?
For the sine 2x plus pi, sine becomes cos, because that's the outside function, and the derivative of 2x plus pi is 2. That's the inside function. Yeah? Because it's just linear. It's just a linear. Yeah?
Log x squared is too long. X, that's fine.
Log x, yeah. is the same thing as that, yeah. Can I scroll down? Yes? Okay, I'll just give you one more. So all these questions I'm doing right now, they're kind of like section A questions, right? They're just straightforward, get the answer, you're finished. So I want to give you a longer one to practice now. It's more like a section B question. So do you have that? Do you need a minute or do you? Yes? Okay. Find the inflection point on y equals e minus x squared. Oh, and there's going to be two answers here. So find the inflection points. Is there? Okay, I thought there was two for this.
And one. That's it.
It's just the one?
Yeah, it's just one. Literally one.
Okay. I don't know if I believe you, but okay. We'll
This
check.
This is the graph.
It's gone now. You cleared the graph.
Oh. This is the graph.
Could you zoom in on that?
Yeah, that's what you. No, I don't. I don't know minus of plus I got confused about that as well. I didn't touch that.
Let's see. Let's see. Are you sure you did it right?
Yeah.
Are you sure?
Is it wrong? No.
How many derivatives did you get?
One.
Ah, so you did it wrong. You need to go back to your, remember that flow chart I had? You do.
Oh, that one.
Oh, yeah. That thing, huh?
This one. 76.
So you chain rule twice, basically.
Yeah, it looks like it, doesn't it?
Sir,
Yeah.
when you differentiate this, does it come out as minus e minus x?
Well, let's do it now. Your scarf was only €6. Amazing.
It was on sale.
Pennies?
No, H&M.
Oh, fancy. Okay. Probably should cut that off later, unless you want people to know. It's a good price for H&M. They're kind of a pricey store.
It was like 75% off.
Yeah, no, I believe that, yeah. Okay, let's have a look at this. You think you can get it? Yeah? Okay, just one more minute. You differentiate twice?
Yeah, is this right?
Checks out. Looks okay.
Just rip it off.
I no, don't. Oh, okay. You'll tear the
Yeah,
scarf.
big
Yeah.
scissors.
No, don't pull it. Cut it with the scissors. Don't pull it. No.
Oh my god, I could
You can just do this.
Oh, fine, okay. Alright, let's have a look at this now. So, first we differentiate, and we need the chain rule. So that's e minus x squared times
Oh.
minus 2x. Yeah?
Yeah.
But inflection point, we need to look at the second derivative. So the second derivative, we need now the product rule. So differentiate e minus x squared again. That's chain rule again. And then keep the other guy the same. Then keep the first guy the same. And differentiate the second guy. Now, what do we need for an inflection point? Well, we definitely need the second derivative to be 0 for an inflection point. But that doesn't guarantee that we have an inflection point. It depends on what happens with the first derivative. So, if I put this equal to 0, I can cancel out this, and I'm left with 4x squared plus 2 equals 0. Is that right? Sorry, minus 2 equals 0. So then I get 4x squared equals 2. X squared equals a half. So x equals plus or minus 1 over 2. Yeah. If you were to put that back into here, do you get positive or negative? Well, if you put in the positive one, you'll get negative. And if you put in the negative one, you get positive. So let's see what each answer represents. So let's have a look at the first one. X equals 1 over root 2. The first derivative is negative, and the second derivative is 0. So I think that is a fallen inflection point. It's like this. No, that's not quite right. It's it's hard to draw.
Negative.
Let me go to my table we had on
it's
page
falling in
76.
inflection.
Yeah, it's fallen in inflection. Yeah, so it was like that. And the second answer, x equals minus 1 over root 2. The first derivative is positive, and the second derivative is 0. So that's rising inflection. Now, I'll actually draw the graph more precisely for you. So the graph looks like this. So it's kind of hard to see, but this is the fallen inflection point, because here, this shape is concave, and this is the inflection point because it switches from being concave to here being convex, and here this is convex, so this is the other inflection point. And these are both at 1 over root 2 and minus 1 over root 2. So this would be an example of a section B question. It's a little bit more involved. They won't ask you to draw the graph of this total shape here.
I don't mind.
Yeah.
For the first derivative,
Yeah.
e minus x squared.
Yeah.
Why isn't it negative e negative x squared?
Isn't it like minus e and x?
Yeah, I understand what you're saying. So if you have e minus x squared and you want to use the quick chain rule, in your head you need to picture it like this.
It's
E
just
to a
the-
something. And that something is the whole thing. So you know EX becomes EX. I know what you're thinking of. I think we had a rule that said like EKX.
Yeah. Equals k.
Yeah. Yeah. So if you do it like that, that's fine, but you'll get the same answer as me. So if you think about it like this is the outside and this is the inside, then differentiating the outside becomes minus e minus x squared, but differentiating the inside becomes 2x. So you get the same answer. So that's fine, but don't count the minus twice. You're either saying the minus is in the outside function or it's in the inside function, but don't count it twice. Is that okay? Yeah? I've lost where I was. Where was I? Oh, here it is. Okay, did you write this down? Yeah? Let's have a look here.
Practice question.
Okay, yeah. I'll let you try these for a few minutes. Practice a couple of chain rule questions. Like I said, in the exam, they like to ask you questions where you need the chain rule and another rule. So, in question 1, they're all examples of just needing the chain rule once. Whereas in question 2, you can see that they're all examples of where you need the chain rule and something else, like product or quotient. And then number 3, you can see, is where you need all 3.
Yeah. Yes.
So I have a question.
Yeah. Okay. If you can just start those now. Can I close this? Okay. Yes. Question.
So, so basically, according to this,